Hey guys, so I apologize in advance for my voice. I'm like sucking out a cough drop and drinking tea, and I can still barely talk. I'm gonna do my best. So, for today, we're going over trig identities and solving trig equations. So, the warm up, I'd love for you to try on your own first. I'm just gonna talk through it. So, what we're looking for is where is sine -1/2 on the circle, and it happens twice on the circle. If we look at the circle, we've got all students take calculus. So the two places sine is negative are down here. So that would be sine, my x value would be 7 pi over 6 and 11 pi over 6. So both of those fit sine of x equaling -1/2. For the next one, I could rewrite this as tangent x squared equals 1. And then we'd like to get rid of the squared so we could solve for x. So I'm going to take the square root of both sides. So this means that tangent x equals plus or minus 1. So we're wondering where in the unit circle is tangent plus or minus 1. So that means it's for the positive and the negative. So that's going to be every quadrant because tan is going to be positive or negative in each quadrant. And that's at the pi over 4s. So my x is going to be pi over 4. 3 pi over 4, 5 pi over 4, and 7 pi over 4. The last one, it really deals more with what we're doing today, which is solving trig equations. But you'll notice this is a squared term, this is an x, and this is a constant, so we can factor. What I would recommend doing is the u substitution we talked about earlier. So I'm going to set u equal to cosine x. So this is going to turn into 2x squared, or 2u squared, sorry. 2u squared plus 3u minus 2 equals 0. So if we factor this, or we can do quadratic formula, whatever you like, you're going to get 2u minus 1, u plus 2. And then we can set each of those equal to 0. When I do that, I'm going to replug in my cosine. So I'm going to have 2 cosine x minus 1 equals 0. And cosine x plus 2 equals 0. Here I'm going to add over 1 and divide by 2. So I've got cosine x equals 1/2. Here I'm going to minus over the 2. So cosine x equals -2. Nowhere on the circle does cosine equal -2. So this is not going to be an option. But cosine does equal 1/2. So the quadrants where cosine is positive is the first quadrant and the fourth quadrant. So x is going to equal pi over 3. And 5 pi over 3. So we're going to do a lot with this stuff today. So the next part, we're just going to go over briefly because you guys should have had a lot with trig identities last year. So this should be familiar to everyone. Cosecant is 1 over sine. Sine is 1 over cosecant. Secant is 1 over cosine. Cosine is 1 over secant. Cotangent, 1 over tangent. Tangent, 1 over cotangent. So I didn't put that on your notes. If you want to scribble it down somewhere, you can. But I just kind of expect you guys to know that. For our class this year, we're not having you graph cosecant or secant or cotangent by hand. But I did want to show you the pictures because it's going to matter for when we do odd and even functions. So this is our graph of cosecant. Notice that it's kind of like the opposite of the sine graph. So the sine graph's in red and the cosecant's kind of on the bumps. And secant is the opposite of the cosine graph, which is like the dotted black line. And then the red lines are the secant on the bumps. So you'll notice the secant graph is reflecting across the y-axis. So we know something about symmetry there. And this one is reflecting around the origin, which also means something for our symmetry. This is cotangent. So you can see it looks similar to tangent, but not quite. It's kind of flipped the other way. It's starting high, ending low, and it's shifted over. This one is not symmetrical around the y-axis. Instead, this one's also symmetrical around the origin. So that'll matter for the next part. So even and odd identities. So even functions have symmetry across the y-axis. Odd functions are symmetry across the origin. So this is on your notes. So which of the 6 basic trig functions are even? So if you look at this, this has symmetry across the y-axis. So cosine of x is even. And then when we were looking at those other graphs, your secant is also symmetrical across the y-axis. Which leaves sine is odd, because if you rotate it 180 degrees around the origin, it looks the same. Cosecant, tangent, and cotangent. So all of these are odd functions. So what does it mean to be even and odd? So we've already talked about this. But remember, if something's even, then when you plug in a negative x, you're going to end up with the original function. And if it's odd, you're going to end up with the opposite function. So based on which ones we know are odd and even, your sine is odd. So that means if you plug in a negative x, you're going to end up with negative sine x. Cosine's even. So if you plug in a negative x, you should end up with just cosine again. Tangent was odd, so you're going to end up with opposite of tangent. Cosecant was also odd, so you end up with opposite. Secant's even. And cotangent is odd, so we end up with the opposite. So these are useful when you are doing proofs or simplifying for when you're solving equations. These next identities, the cofunction identities, I'm not going to spend a ton of time on. I just want to kind of show you them. This is not on your notes, or at least this picture isn't. What I want you to see is that if you do sine of pi over 2 minus theta, if I rearrange this and look at the transformations, if we want to put our theta first, I'd have minus theta plus pi over 2. We don't like that minus with our variable, so I pull the minus out, and then we got theta minus pi over 2. So that minus is doing a reflection across the y, and the minus 2 is doing a shift to the right by pi over 2. So when you do those transformations, your sine graph all of a sudden is a cosine graph. So whenever you see sine pi over 2 minus a theta or an x, that's going to equal cosine. Same with tangent. If you do tangent of pi over 2 minus theta, you could do those transformations again, and it's going to turn into cotangent. So if on your notes on the back, I just gave you a list of the different identities, and I just want you to fill in what each of them equal, because it might be useful. I know on your homework I saw at least one. So write down those identities. Okay. What would a math lesson be without mention of Pythagoras? A very sad lesson, just like my voice. All right, Pythagorean identities. We should be on top of these from last year. Sorry. All right, so we know sine squared plus cosine squared equals 1. So we can just rearrange that multiple times. You know that 1 minus cosine squared theta equals sine squared theta. 1 minus sine squared theta equals cosine squared theta. So very exciting. These are important. You should know these. Using those, we could also come up with our other identities. So say I divided all of these by sine squared theta. You know, just on a whim. So if I were to do that, sine squared divided by sine squared is just a 1. Cosine divided by sine is cotangent. And 1 divided by sine is cosecant. So this is another important identity that you should know. For the other one, starting with the same identity, if I now just divide by cosine instead of sine, notice you can derive all of these. You don't have to memorize them as long as you can just go through steps to derive different identities. So sine divided by cosine is tangent squared theta. Cosine divided by cosine is 1. And 1 over cosine is going to be secant squared. So this is another identity. So this should be a review from last year. And remember, you can rearrange these to get like cotangent by itself, tangent by itself, however you want to rearrange it. So some quick examples. Use the basic identities to simplify the expression to either a constant or a basic trig function. So here is that cofunction identity again. So we know that sine pi over 2 minus x is the same as cosine, so I can just rewrite this as cosine x. And I still have secant x. Another way to rewrite secant could be 1 over cosine. We're still multiplying by cosine. And boom, they simplify, you're left with 1. So that's pretty nice. Over here, I'm going to start with distributing that negative. So I'm going to have secant squared x plus cosecant squared x minus tan squared x minus cotan squared x. So far I'm not seeing anything I can simplify, but we learned an identity for something that secant squared x equals. So I can rewrite this as tangent squared x plus 1, and that equals this. Cosecant squared, we know, equals 1 plus cotangent squared x. And then I can just fill in everything else I have. So from here, we've got a tangent and a minus tangent, so those go. A cotangent and a minus cotangent, so those go. So all I'm left with is 1 plus 1. So my answer is 2. So that's a nice way that your identities can help you simplify. So that is the end of these notes. So now we're going to go on to equations. So this is the second handout you have. So flip to your solving trig equations handout. This is also we're going to finish this for homework if we don't get it done today. So from your original homework, I want you to cross off 19, 31, 61, 69 through 73 odd, because you don't need to be doing all of this work. So cross these off, and you're going to finish whatever we don't get done for homework. I'm going to pause there because my video time is almost up, and I'm going to start another video. So click on the next video to start doing solving trig equations.